online members, faculty members, SEECS, Majid sir, and other participants. Assalamu alaikum. I welcome you all on this workshop on IPv6. We will be conducting this workshop from 11 o'clock till 5 o'clock. We'll have some breaks in between. You might have received that plan for the workshop for today. So I'll start with the introduction of the workshop and then a brief introduction of the topic, because we have experts in these areas and they will be elaborating more on this area. The main workshop modules are, like I'll be presenting the introduction of the topic and the objectives, why we are gathered here, what are the objectives we are going to achieve from this workshop, and then there are some details about a project which is called V6 Code Project, which will be presented by IPv6 Task Force. Mr. Aftab Siddiqui is here from Karachi, who will be participating online. Then technical details of IPv6 and the complete, I would say, introduction and all the details will be presented by Mr. Majid Siddiq, he's from Cisco. And then IPv6 research and development will be presented by Dr. Adnan, the faculty member at SEECS. And at the end, we are going to show you a demo that how IPv6 is implemented, how we are going to test that, and what services IPv6 can offer on a local network. Okay. A brief objective: capacity building and promoting IPv6 awareness. Because at this moment we don't know how many people are skilled in IPv6, how many of you already know IPv6, or how many people are there who can configure IPv6. So the first objective of this workshop is to capacity build, like to produce people who have technical sound knowledge for IPv6, and then public awareness that IPv6 is a thing that is going to happen. Second objective of this workshop is accelerate adoption and integration of IPv6 in Pakistan. We see that different countries, they are far ahead in IPv6 implementation, but for Pakistan we are lagging behind. So we want to focus this and converge our efforts on this target. And the third objective of this workshop would be bridging the industry-academia gap. Because in Pakistan we lack this kind of relationships. Today we have invited people from industry as well, Cisco, Cybernet. So we are trying to find common areas of interest so that we can work together. And finally, stimulate interest in research and development, because we are our university and our main focus would be to do research and develop new protocols for this. So all of us, we should be on the same page as far as the objectives are concerned. Now the question comes that why we need IPv6? Is there any problem with IPv4? The people coming after me, they will elaborate more on this, but I'll just give you a small introduction here. That IPv4 started around 1970s, the discussion on IP address. We are familiar with IP address, right? Okay. So in early 90s, concern was raised that the addresses are limited and devices are increasing every day. Billions of devices are there on the internet. So we should come up with a new addressing scheme. So in 90s there was with TCP and UDP with big addresses, and then simple internet protocol, and then common architecture for internet. There were some proposals to converge or to address this problem of shortage of address space. But in 1990, IETF began a framework for IPv6, and they have published a first RFC, which is 2460, mid of 90s somewhere. And then after that, we nearly see 200 RFCs on IPv6 till today. Address allocations. I am saying again and again that we are short of IPv4 addresses, but we should know what are the current statistics. So if we see that this information is presented by number resource organizations, 31% or 34% was ethnic's share in which was allocated for IPv4, and ethnic has already used 29.1% of this share. So it means that we are going to exhaust IPv4 addresses very soon. How soon? We can see these dates here. Projected IANA poll exhaustion is September 2011 worldwide, and then ethnic, which is for Asia Pacific, it is November 2012. In Pakistan, we are a bit safe if we say we are going to deplete IPv4 addresses in 2014. Okay, but we have to start something now so that we can bring those technologies together, because IPv4 will exist with IPv6. So we have to come up with certain technologies that can support these things. At the end, I would like to quote a quotation from Windsurf. He's an expert, and known as father of internet. So he says here some researchers wanted, it is in 1970s, some researchers wanted a 128-bit space for the binary address, but others say that that's crazy. Why we need 128-bit addresses? Because it's far larger than necessary. Because at that time people didn't know that, today I want to connect my laptop, my mobile, my gadget over the internet, and for that I need an IP address. So he suggested that, okay, finally settled for 32-bit space that was incorporated in IPv4, 4.3 billion separate addresses. The problem after that, he says, it's enough to do an experiment. 32-bit address is enough to do an experiment. He said the problem is the experiment never ended. And we see today that, every now and then we have new networking technology coming up. We need communication, we need security, we need wireless access and other things. So I'll conclude my talk with a 5-minute presentation, animation about IPv6, so that I'll pass over the presentation to Mr. Aftab afterwards.
IP version 6, or IPv6 for short, is a new version of the Internet Protocol designed to replace IPv4, the Internet Protocol that is predominantly deployed and extensively used throughout the world. Although the exhaustion of available IPv4 address space has been the primary reason for the development of a new protocol, the designers of IPv6 have added many new features and a number of critical improvements to IPv4. IPv4 has stood the test of scaling an internet work to a global utility the size of the internet today, but IPv4 wasn't initially designed to support a high number of network equipment. Because of the recent exponential growth of the internet, IPv4 is unable to satisfy the potential huge increase in the number of users or the geographical needs of the internet expansion. As a result, IPv4 address depletion is approaching quickly. Additionally, emerging applications such as internet-enabled PDAs, home area networks, mobile ad hoc networks, IP wireless services, and integrated IP telephony services require a new internet protocol. The lifetime of IPv4 has been extended using techniques such as address reuse, with network address translation, or NAT for short, classless interdomain routing, or CIDR, and temporary address assignments such as the Dynamic Host Configuration Protocol, or DHCP. These techniques appear to increase the address space and satisfy the traditional server-client setup, but they fail to meet the requirements of true network and user mobility. Applications need an increasing amount of bandwidth, while address translation has a performance impact on the network equipment. Next, the need for always-on environments to be contactable prohibits these IP address conversion, pooling, and temporary allocation techniques. Furthermore, the plug-and-play feature required by consumer internet appliances further increases the protocol requirements. Millions of new technology devices, such as wireless phones, PDAs, cars, and home appliances, will not be able to get global IPv4 addresses any longer. IPv4 will soon reach the stage where a choice has to be made between either new capabilities or a larger network, but not both. In other words, we need a new version of the IP protocol to provide new and enhanced features in addition to solving the IP address exhaustion problem. That new version of IP is IPv6. IPv6 is designed to meet the requirements of the potentially huge internet expansion. It will allow a return to a global environment where the addressing rules of the network are transparent to the applications again. Through auto-configuration and plug-and-play support, network devices will be able to connect to the network without manual configuration and without any bootstrap services, such as DHCP servers. IPv6 succeeds in doing this by providing the following benefits to network and IT professionals. First, IPv6 has a larger address space for global reachability and scalability. This will result in an almost unlimited number of IP addresses and a hierarchical network architecture for routing efficiency. This eliminates the problems associated with NAT. The ability to provide global addresses for each network device enables end-to-end reachability, and network management will be simpler and easier. Second, a simplified header format for efficient packet handling. 6 of the 12 IPv4 header fields have been removed in IPv6. Some IPv4 fields have been carried over with modified names, and some new fields have been added to improve efficiency and introduce new features. Third, a hierarchical network architecture for routing efficiency that follows some of the IPv4 CIDR principles. Another important IPv6 benefit is the embedded security with mandatory IPsec implementation. While the use of IPsec is optional in IPv4, IPsec is mandatory in IPv6. IPsec is part of the IPv6 protocol suite. Therefore, network implementers could enable IPsec in every IPv6 node, potentially making the networks more secure. Additionally, IPv6 offers an increased number of multicast addresses. IPv6 will not use broadcast, leading to a more performant network. Moreover, in IPv6, the ICMP protocol has been revised. ICMP version 6 has become much more powerful and includes new functions to support auto-configuration, neighbor discovery, and multicasting. And finally, IPv6 offers built-in mobility as the anticipated large rollout of wireless data services.
Okay, so that's about a small introduction for IPv6, just to open up your mind that what we are going to discuss in this. So now I'll pass over the presentation to Mr. Aftab Siddiqui in Karachi, and let me introduce Mr. Aftab. Aftab sir, can you hear us?
Yes, very loud and very clear.
Okay, that's alright. So I'll introduce Mr. Aftab Siddiqui here. Mr. Aftab has 6 years of industry experience. He holds a MS-IT degree, and he's working as an assistant manager. Network operations at Cybernet Karachi. He's also a member of South Asia Network Operators Group, Program Committee, Fellow of Asia Pacific Advanced Networks, and member of IPv6 Task Force Pakistan. So please welcome Mr. Aftab online. Yeah, Aftab sir.
Assalamu alaikum everybody, and good morning. So we still have time to say good morning. So thank you, Adnan sir. It's my pleasure to be part of such a huge audience, like diverse audience I would say, but very technical and very relevant. I've been speaking about IPv6 for quite some time, but mostly to students, which is quite fascinating but not so productive most of the time. So most probably today I will come out with something interesting which will help the industry and the academy as well. So to start with the presentation, let me just share my presentation. Just give me a second. Okay, can you see the presentation now? Can you see the presentation now?
Yes.
Okay, I just heard yes. I believe there is a delay in voice, so I will try to speak a bit slowly, or maybe I feel like that. Anyway, to start with the agenda, we will be discussing a little bit about IPv6 and what IPv6 is in terms of technical ground, because I've been told that Majid is here, so I would rather spare myself get into the technical details, because nobody else better than Majid can explain all the technical details of IPv6. He's just a great guy. Anyway, and then we will be discussing the depletion of V4. You have just seen a little bit of depletion status in non-sub